Last time on Friday, we talked about using the periodic table that I had on your worksheet, okay, or attached with your worksheet online. It looked like this, okay? And it had, morning, Chris. I think that's Chris. It had all these different numbers on here. So this was a specific type of periodic table based purely on electronegativity, okay? So if you look at these numbers, a 2.04, 2.55, 3.04, these are the numbers that you're going to look at. And I'm going to cut out all of the, good morning. Get some more people in there today. Oh, it's Brian. My bad, Brian. I'm going to cut out all the theory today, okay? So we're not going to talk at all about theory. We're not going to talk about why these numbers are the way they are or what they even mean. All we're going to do is we're going to look at a table, okay? So the numbers that you have to choose from, the type of bond, for instance, the type of bond, okay? There are three types of bonds that you need to know. You need to know ionic, you need to know polar. And for today, I don't want you to I don't really want you to be concerned about what these mean, okay? I just want you to know how to calculate them. Because once we figure out how to calculate them, morning, Cassie. Once we figure out how to calculate them, then that'll make this process significantly easier once I start talking about what these bonds do and what they mean in terms of, water or how things dissolve or why they dissolve, so on and so forth, okay? So we have ionic, polar covalent, and then we have non-polar covalent, okay? And all you're looking at is the difference, okay? The number difference between the two elements, okay? That's all we're looking at. So if the difference between, remember that difference means what, y'all? What does difference mean? Subtraction, right? Subtraction, okay? So we are subtracting these two numbers. And in math class, you guys learned about this thing called an absolute. Exactly, thank you, Siri. You guys learned about this thing called absolute, right? So absolute means that the number difference can't be negative. You can't have a negative value for electronegativity difference. It has to be positive because the lowest value you could possibly get is 0, okay? The electronegativity falls between 0.3 and 4.0, okay? This is going to be francium or cesium, and this one is fluorine, okay? Most of the noble gases that are on the far right side of the table don't actually have an electronegativity. Helium, neon, argon do not. But krypton, xenon, and radon do. Okay, so the number difference, okay, is going to fall between anything greater than 1.7. All right, is going to be considered ionic. Anything greater than 1.7, the difference, the subtraction between the two values. For polar covalent, it's going to be 0.3 to 1.7. And this is going to be anything less than 0.3. The first two elements that we have here, we have calcium and we have chlorine. All right. Okay, we have calcium and we have chlorine. So what we're going to do is we're going to write out calcium and chlorine on here, okay? So number one, and we'll just call this letter A because that's what it is. So it's calcium and chlorine, okay? So what we're going to do, we're going to use the table that we have, and we're going to find calcium. And calcium sits right here, and the number below calcium is 1.00. And then we're going to go over here to chlorine, and you guys probably won't be able to see this because it's too dark, okay? But it says I think that's 1.5. 1.6. Those are the ones that you need to be able to write down. Or you just look at it on your own computer too. That'll work. Okay, so we're looking at chlorine at 3.16, and we said that calcium was 1.00. All right, so what we're going to do, we're going to write the numbers below the elements. And we are going to subtract these two because we are looking for the change in electronegativity. And that will tell us what type of bond we have. So we're going to calculate this. This number comes out to 2.16. Now I know what you're saying. That should be negative, right? 1 minus 3.16 should be negative 2.16. But remember that the absolutes here, these bars meaning absolute, it's always positive. Okay? Always positive. And if you know that, you don't really need to write the absolutes on there. Okay? Just write out the positive value of it. Instead of it being a negative 2.16, it's a positive 2.16. So this number, 2.16, falls greater than 1.7. And in case you don't remember, this means greater than. Okay? Greater than. And this one means less than. I know in high school, not in college, but in high school, I could never remember which way they went. And the Pac-Man thing didn't work out for me very well. I didn't quite understand that either. Because Pac-Man always made sense that I was eating something, so I was getting bigger, not smaller. So, I don't know. 2.16 is the difference between these two values. So, therefore, the bond between calcium and chlorine should be an ionic bond. Because 2.16 is greater than 1.7. All right? A 1 through 5. A 1 through 5. 1 meaning I don't get this at all. 5 meaning I can teach this to somebody else. Where are you? 1 through 5. Catch up later. All right, so the next one, number 1B, this is letter B on your worksheet, is going to be carbon and sulfur. Okay? So here's what we're going to do. You guys tell me what carbon is, and I will tell you what sulfur is. So you guys tell me what the electronegativity for carbon is, and I'll tell you what sulfur is. Okay? Just put it in the chat. Sulfur is 2.58. 2.58. Where does that number come from? Where does that come from? Where does that come from? From the periodic table. Okay? The special periodic table, not the regular one, right? So somebody tell me what carbon is. What is carbon? 2.55. That's right. How'd you get that? You got that because you looked at the periodic table, right? So if you look right here, and I know you probably won't be able to see this on the live, but there we go. You can see it's 2.55. So the number that Jonathan was giving me is right here. Okay? Now, in a lot of the periodic tables you're going to use, or a lot of the charts and stuff that you're going to use, this number right here will actually be 2.5, and that's okay if it's 2.55. This table is just a little bit more specific. I guess I could have chosen one that only went to the 10th spot. You can't do the 1 spot because the 1 spot's too generic. So you have to have a little bit more differentiation there. So 2.55 is going to be our electronegativity for a Google Classroom. Yeah, that'll work too. 2.55 is going to be our electronegativity for carbon, and sulfur is 2.58. So the absolute difference here is 0.03. Okay? So if it's 0.03, and we go look at our table up here, this number is less than 0.3, which means that this bond would be a non-polar covalent bond. Okay? So it is a non-polar covalent bond. Non-polar covalent. Okay? Non-polar covalent. Okay? So, polar covalent, exactly. Okay. So, what does that mean? That means the majority of bonds, y'all, and in terms of the ones that actually do a lot of the bonding and a lot of the holding things together, almost like glue, okay, are going to be these polar covalent type bonds. Ionic bonds are going to be like salts, and then non-polar covalent are going to be typically just elements. Good morning. Okay, they're going to be just typically elements like N2, O2, Cl2, F2, I2, Br2, H2. Those are going to be your non-polar covalents. Most bonds are going to be polar covalent or ionic. All right, we skipped section 2. Now we can go to section 3. Section 3. All you're looking at, this is electronegativity difference. That's what we just did here, right? That's what we just did here, okay? So if it is electronegativity difference between P and Cl3, all we're looking at is P minus the Cl. We're looking at the absolute difference between those two. So that will give us this bond. The type of bond, we're going to use a table to find the type of bond. And then the atom with the greater electronegativity, well, that's whichever number over here is greater. Okay, so let me do a couple problems with this. All right, let me do this whole front page right here, and then you guys can do the back for the homework. Okay, I did extend your due date to Tuesday at midnight, or Tuesday at 11:59 p.m. technically. So make sure that you guys check that out. Okay, I am gonna get your grades in today as well. All right, I didn't get that done last week, but I also did a lot of editing. I spent almost all day Friday after live doing editing. All right, so P and Cl. Even though it says PCl3, we're still looking at the bond between P and Cl, okay? So phosphorus is 2.19 and chlorine is 3.16, okay? So phosphorus is 2.19. Minus chlorine, which is 3.16, okay? And we're looking at the absolute difference there. So our absolute difference is going to be 0.97, okay? 0.97. So if we look at our table up here, 0.97 falls between 0.3 and 1.7, which tells me it's going to be polar covalent. And the atom with the greater electronegativity is going to be chlorine. All right, so N minus the H. N we said was 3.04 minus 2.55 or 5, no, 2.20. I'm sorry, wrong number. 2.20. So that means that we're looking at 0.84, which falls between 0.3 and 1.7. So this is a polar covalent, and the bond with the atom with the highest electronegativity is going to be nitrogen. All right. So you guys do these bottom two.